Hello friends, let's continue with our series. For the lecture number 20, we will be learning about k-means clustering. Let's begin. What is k-means? It is a popular unsupervised learning algorithm which is used for clustering, right? It groups data points into clusters based on similarities. Alright, so this is basically an unsupervised learning algorithm. It is used for clustering, or you can say grouping. It groups data points into k clusters, meaning k number of clusters based upon the similarity. All the similar data points will be grouped in single group, and all the different data points which in themselves are same will be grouped in another group. For example, those who like to drink coffee will be in group A, those who like to drink tea will go in group B, and those who like to drink water would go into group C, and so on. So based upon this, we will have k different groups or k different clusters. So how it works? It chooses the number of clusters, which is k. It randomly places k centroids. It assigns each point to the nearest centroid. We calculate centroids as the mean of points in each cluster. Repeat until the centroids stop moving or changes are minimal. Right? So how does it work? First of all, we have to decide a number of clusters, which is k. Then we randomly place k centroids anywhere where we like. After that is done, we assign each point to the nearest centroid. So if there are 100 points on our map, we will assign all of those to, let's just say, 6 different centroids, and only to the one at which they are the nearest. Once that is done, we will recalculate centroids as the mean of points in each cluster, right? We'll find out the mean of the points inside a single cluster, and we will do that for all the clusters. Once that is done, we will repeat this until the centroid stops moving or changes are minimal, right? So you have to stop when your centroid stops moving or the changes are very negligible, because that's when you know you have found the right centroids. So why do we use this algorithm? It is simple to run and also fast to execute. It works well when clusters are spherical and equally sized, right? So it is known to be working best when our groups are spherical in nature and equal in size or similar in size. You know, it helps in finding patterns or groups in unlabeled data. So this will basically help you in finding the patterns or the groups inside an unlabeled data or inside an unlabeled data set. And where can it be used? It can be used in customer segmentation and marketing. It can be used in grouping similar documents on products. It can be used in image compression and color clustering, right? And what are some of the limitations? The limitations are, you need to choose k manually. You need to choose the number of clusters yourself. It doesn't work well with non-spherical clusters or outliers. So whenever we have a cluster that is non-spherical, or whenever we have a data with some outliers, this will not work very properly. Why? Well, because an outlier lies far within the data set and much outside of our range where we will be making clusters. If there are outliers, the line or the centroids will be very hard to manage and hard to make, and this is why you will not get a very realistic value using this. And finally, it is sensitive to initial centroid positions. So when you mark 5 random central centroids, you are allowing the algorithm to correct them, to place them in the right places. But if you have done two of the centroids very close to each other and two of the centroids very apart from each other and also far from their typical center position, do you think you will get a very accurate result? You probably won't, and this is why it is sensitive to initial centroid positions. Well, that was it for this video. I hope you were able to understand, and thank you for watching.